And best wishes to Mr. Regan and Mr. Palin Visu and Mr. Ayyappa Srinivasan and team for the successful organization of the program. And thanks to the management for this wonderful opportunity. So have a good time. Thank you.
Thank you, sir. Good evening, participants. Now, let me tell before we proceed, I would like to bring your attention to some important guidelines to ensure the smooth and productive session. First of all participants are requested to join the sessions on time. You can join through the link shared in WhatsApp or your registered mail ID. The participants must have 80% of attendance and 75% of scores in their assessment to receive the certificate. During the session, please keep your microphones muted unless you are invited to speak. Also, you may use the chat box or raise your hand for the questions. The next important thing is at the end of the program, at the end of the each session, all the participants will be requested to submit feedbacks for quality improvement. Participants, those who are joining through YouTube live session, should send their name and college details in the chat box. We appreciate your cooperation and in following these guidelines as they are designed to ensure a valuable experience for all. During the sessions, once again, all are requested to mute your mic and please rejoin at 6:30 p.m. So, thank you. Thank you so much, sir. Thank you.
So participants, please rejoin the meeting at 6:30 p.m. using the same meeting link. Thank you.
Sir, kindly wait. The session will start by 6:30 p.m. Thank you.
Once again, I welcome all for this FTP. The first session will be handled by Dr. Sandosh Paramasivam. Very happy to introduce Dr. Sandosh Paramasivam. He is a distinguished scholar and professional with an impressive academic background. He earned his bachelor degree in electrical and electronics engineering from Anna University in 2008, followed by a master degree in power electronics and drives from Karpagam Academy of Higher Education in 2011. He then obtained his PhD in electrical engineering from Anna University in Chennai, India in 2019. As a dedicated member of prestigious professional organizations such as IEEE, ISTE, IANGE, ISRD, and IACGT, Dr. Sandoz has made significant contributions to his field. His research efforts have led to the publication of over 30 articles and 4 patents. Dr. Sandoz has demonstrated his commitment to advancing power electronics by securing a substantial grant of 9.1 lakhs from the All India Council of Technical Education. This funding was allocated for the moderations of the power electronics laboratory at Sri Krishna College of Engineering and Technology in Coimbatore. Known for his expertise, Dr. Sandoz has received as a featured speaker and resource person in more than 50 sponsors faculty development program and short-term training programs in across India. His contributions have been recognized with awards such as the Best Paper Award and Best Faculty Award. This research focuses on sustainable energy harvesting, DC to DC power converters, optimizing charging circuits for electric vehicles, and AI-based life cycle assessment of second life and third life lithium batteries. Currently, he is associated with the Department of Electrical and Electronics Engineering at the University of Cagliari, Italy, specifically within the scientific discipline of industrial and information engineering. Dr. Sandoz is actively participating in PNRR projects, further solidifying his commitment to cutting-edge research and development in this field. I welcome Dr. Sandoz. Welcome, sir. I welcome you, sir. Now I hand over the session to Dr. Sandoz.
Thank you, sir. Thank you for your nice introduction. And good evening to everyone present here. So it's my pleasure to be a part of this ATAL FDP. I thank the organizers for this opportunity. Myself, Dr. Santosh, and the topic today we are going to discuss is sensors and its role in AI era. Before moving on to the session, so let me give a short overview of what we are doing here or I am involved in. As he was rightly saying about I think one of the participants' microphone is turned on. So what happens is that it after a delay it is being repeated. I request the participants to mute yourself so that we will not have multiple overlaps. Thank you, sir. Fine. So as Professor was rightly saying, so thank you, sir. As he was rightly saying, I am involved in PNRR project. Specifically, the project which I am involved is called as Return, which is multi-risk science for resilient communities under changing climate. This is the project which I am involved in. So what we do in this project is that, see, the climate change is a very big problem which the world is facing now. So here we are working on things how we can. So still I'm getting an echo.
Participants, kindly mute your microphone. Then only we can hear the session in a clear manner. Santosh sir, you can continue now, sir.
Thank you, sir. Do we still hear an echo?
No, sir, I am not hearing. Your voice is so audible right now.
Thank you, sir. Thank you very much. Fine. So let me move on to the next slide. So which this is the project which basically I am working on. And then before moving on to the again sensors and other things, we should know why we are nowadays going for this. The most important aspect of going for AI and other things is this: the sustainable development goals. There is some UN sustainable development goals to which all the entities in the globe are working towards. There are 17 goals which have been stated by UN. Each of these goals are actually related to one. How these goals are related? You can see that starting from no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation, infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice, and strong institutions. And the last one is partnership goals. Here it has been ranked from 1 to 17 in the order which is that it has to be given priority. But these are connected one to one in a manner we attain one another from other. So how it goes is given here. So this clip explains how it goes. I'll just once again play this so that we just get a sequence of it in a better manner, because it was a short video which played very quickly. So 1 to 1, how we got it. So we may not be able to observe easily. So let me play it once again so that we get it clearly, right? Yeah. Once again.
Santosh sir, your mic is muted, sir. Sorry, sir. Sorry for the interruption.
I hope now my mic is unmuted.
Yes, sir. Yes, sir. Thank you, sir.
Yeah. Out of the 17 goals, you can see here there are 8 goals which have been given. What or why these 8 goals is that those 17 again. No, sir. My mic is not muted. It's unmute actually.
Yes, sir. Audible, sir. Audible, sir. Yes, sir.
Sir. Okay, fine. So now we saw 17 goals. Here in this particular slide, I have highlighted 8 goals. Why these 8 goals? These 8 goals, every individual can contribute to these 8 goals, by which we will be able to attain all the 17 goals. And if you observe here, these 8 goals are the areas where we have the applications of what we are going to see. Today we are going to see about sensors. Probably tomorrow we will see about the wireless sensor networks. So these are the areas where our applications find in. You can see it starts with sustainable cities and communications, industry innovations, affordable and clean energy. With these, we will come for the life on land, life below land, clean and water sanitation. And then by this partnering all these goals, we will be able to achieve climate change. And the last 12th one is more important, which is called as responsible consumption and production, wherein in this every individual is responsible for the consumption. When it comes for consumption, it includes everything: your water, your electricity, your transportation, whatnot. Whatever you consume every day, if you are very much responsible in that, of course with the help of that we will be able to progress and prosper. So that is why I have given all these goals. Moving on to the sensors part. So here comes it. The flow of the argument today is going to be like this. First we will have a small introduction, and then role of sensors in AI systems, and then potential areas of applications, what is sensor, and then the parameters and sensors and its applicational areas. Then followed by that, we will have challenges and future trends. Finally, we will end with the conclusion. So this is the flow of argument. So when it comes for the first thing, the era of AI, the sensors play a very crucial role as a primary interface between the physical world and the intelligent systems, right? So, of course, they enable AI driven applications by collecting real time data, which is then processed, analyzed, and used for decision making. So, here this is very similar to all our five senses through which our brain gets data and then synthesize the data and analyze and make some decisions. This is very similar to the same act which these sensors are also going to be helpful for us in our automation and other things are concerned. What is a sensor first of all? A sensors are devices that detect physical, chemical or biological changes and then convert them into measurable signals. Fine. The role of these sensors is the primary role is data collection. Sensors provide real-time data essential for AI decision making. So without sensor, whatever AI system we have, it will not be able to make any decisions because we are very much aware all the AI systems, whatever it could be, it needs some input. Even though it has a trained database, it needs some input to check the data. So the data collection becomes very, very essential and sensors play a very crucial part in that. Then comes the purpose. With this, what is happening? With the data that is being collected, it enables the automation. In the sense, the process automation. It is generalized as industries, but wherein it is not only for industries, for many process, we are able to use these sensors or the data is being automated. And then this enhances the accuracy and efficiency of the system. To commonize or to generalize, sensors act as eyes and ears of the AI systems, providing raw data required for machine learning, automation, and intelligent decision making. So, this is the role of sensors in the AI systems. Then, then comes the potential areas of application. Where can we or where and all are we using sensors? In short, in our day-to-day life, in all the applications we use, wherever we go, today we have a lot of sensors that play a lot of roles. But still, when it comes for AI-based automated systems as a whole, there are some key areas which are currently using these sensors and AI integrations. So here we have listed a few of that. So the first is AI data collection for AI models. Then comes the automation and robotics. Then smart cities and environmental monitoring, healthcare systems and wearables. And the last is Industry 4.0 on predictive maintenance. Of course, we have Industry 5.0, which is coming up, wherein the AI part is embedded into the sensor itself. Now, this Industry 4.0 has sensors which are IoT enabled, wherein when it comes for the Industry 5.0 is concerned, they are AI interfaced. So that is how it goes. When it comes for the generalized data collection for AI models, so AI requires a lot of data sets for training and real-time operation. This is well known to us. And then these sensors provide accurate and continuous data streams, improving the AI performance. So when it comes for continuous data, you could imagine the quantum of data that would we be processing. These continuous data, what happens is that sometimes there is a problem of regression as well, but still the initial period or the initial data collections is very much essential for us to enhance our AI models. So the first thing is that irrespective of the application, these sensors are used as data collection entities. And then, for example, IoT sensors in home, smart home collecting sensor, smart homes collecting temperature, humidity, and occupancy data to optimize energy efficiency. As I was pointing out earlier, responsible consumption plays the baseline for attaining all our sustainable goals to enhance the life in the globe. This comes as the first step. And for this, I have also given a case study, so which is AI enhanced airport security system is a case study which will enable us to understand the necessity of data collection for AI models. And also, when you go through this case study, you will be able to analyze and understand the different types of data that is being collected and the role of these data that plays in enhancing the model as well. Fine. Followed by this, the next important area of application is automation and robotics. So when it comes for automation and robotics, earlier it was very close to the industries alone. Very big industries like manufacturing industries and process industries made use of this robotics and automation process. But wherein now, even the small scale industries, medium scale industries, and even in some household applications, we have started using this a automation and robotics. For example, the cleaners we have at home are all examples for the automation we use at home, right? Fine. The AI powered robots and autonomous system rely on sensors to navigate, interact with objects, and perform tasks. So this is where the sensors comes into picture. For example, today we have self-driving cars which use LiDAR, radar, and cameras to detect road conditions, obstacles, and pedestrians. When it comes for the applications, each and every area which I am specifying here has a very big data bank. They have a very big, there are a lot of case studies that are being done. So each of these topics, if you take, it is hours and hours we can discuss over that. But my aim of the day is to give an overview of where are all the applications we are going to use this, what are the sensors that we need, where can we find the sensors, and how can we work with these sensors. This is what I am trying to put light on. That is why I'm just giving a glimpse of the areas, a simple examples, and a case study followed by that, right? So coming back to this particular example or the application area for automation and robotics, the self-driving cars is an example, and Tesla's autopilot can be taken as a case study to understand how these sensors play a key role in automation and robotics is concerned. And then comes the smart cities and environmental monitoring. The AI combined sensor networks help in monitoring the air quality, the traffic congestion, waste management, and whatnot. The climatical conditions of the surrounding are also monitored with these sensors. We will see how to do all these things in the following slides. So for these cases, when it comes for the smart city application is concerned, here, the low cost environmental sensors, you can even skip the word environmental, because when it comes for the smart cities and environmental monitoring application is concerned, there the data collection has to be continuous. When I say continuous, which means we need to collect data throughout the day, across the week, and all along the year. So when you have the complete 24-hour data for one whole year, only then you will have a single data set. So for example, January 1 to December 31, only if you have the complete data sets, it gives you one experience of an year. So how this particular environment is reacting, or how this particular environment is varying with respect to the each day, how the temperature is, how the climate is, how the congestion of traffic is, what are all the drawbacks people face on day by day. All these things can be recorded, and we will have only one data set when it comes for a whole year is concerned. So to have a better understanding, we would require a few years of data, so that to have a basic idea of a smart city environment as well as an environmental monitoring or the climatical condition is concerned. So therefore, when it comes for such an application, the more important part here is the low cost as well as low power sensor are supposed to be used. The power consumption is going to be a very big problem when you use any sensor for a continuous period of 24/7 as well as for a whole year. And why we go for a low cost, low power environmental sensor or sensor is when there is a problem with the sensor, as we know, this is gonna be a continuous process. We should be able to replace the sensor. So replacing a sensor should not be a burden. Therefore, we should find a low cost solution and also a low power consuming solution in this application is concerned, because the number of sensors are going to be also numerous. When it comes for a smart city is concerned, there are multiple one a small city of 5 kilometer radius may require a sensor of 5 million sensor may be required for different parameter monitoring at different places of the city. So you just imagine a 5 million sensor placed in a city which gathers data all along 24/7 for a whole year. Then there are gonna be a lot of data that you collect, point number one. And then the energy utilization is going to be also enormous. So you should also require a big server bank for these data, and you should have an efficient and eminent algorithms to vet out the recursive data and to store only the essential data. So every day the total data that is collected has to be defragmented, and the essential data has to be stored, and the remaining has to be discarded. So this enables us to have the entire data without any modifications or error. So here it comes. Google's air quality sensor project can be taken as a small case study to understand the complexity of this particular application. The next key application area is healthcare and wearables. So yes, of course, today most of us have smart wearables, which is capable of measuring a lot of parameters, like our blood pressure is being monitored, heart pulse is monitored, lot many things are there. But still, how these can be, the AI based model can be used for these is that the first one is remote patient monitoring, then AI assisted diagnostics, and the third one is wearable technology. These wearable technologies which we use nowadays are of course connected to our own mobile phones, but wherein a centralized system is not there in our wearables. When it comes for this application, what we are discussing here we will have a centralized system wherein with that we will be able to do remote monitoring, diagnostics with the help of this wearable technology. So example, we can do ECG analysis, glucose monitoring, and smart processes. So Apple's watch AI powered heart rate alerts is one small case study which will enable us to understand this particular application is concerned. Next comes the most important part of this application, which is the Industry 4.0 and the preventive maintenance part. Why this particular application acts as a key is that here, so far, whatever we have been seeing are all areas which are dedicated to a certain application or certain perspective. When it comes for Industry 4.0 and predictive maintenance, here every individual things whatever we use today, that is starting from our power management to all the manufacturing industries, all the service industries, whatnot, everything comes into picture in this area, which requires lot sensors, and then with which also again the data is becoming very hard for us to store with. Here, the AI-powered sensors in the factories help monitor the equipment, predict the failures, and optimize the maintenance schedule. This is the prime applications of all these things. So primarily here, one important sensor is that the vibration sensors in the manufacturing plants to detect early sign of machine breakdowns and reducing downtime. And for this, the General Electric's predictive maintenance case study will help us to understand this much better. Again, this is one key area where sensors have been in use since a very long time. Maybe a minimum of 5 decades would be there in this area. And the numbers has gone up now. For example, not one time or two time, nearly more than 10x times the number of sensors that is being used has been increased here. Fine. Then comes to the part of sensors. What are all the generalized sensor parts? Of course, we have different application we have seen so far. So in these areas, the sensors which we use can be generalized into key areas. So let us see what are the key areas in which these sensors can be generalized. As again, the sensors are devices that detect and measure physical or environmental changes and convert them into electrical signals for processing, right? So this is a generalized way in which we can categorize the sensors. So when it comes for the general forms, the motion sensors, optical sensors, biometric sensors, environmental sensors, and acoustic sensors. These are the 5 areas of categorization of sensors. So far, we have been seeing about the key areas of applications of these sensors integrated with AI. And now we are categorizing the total sensors, whatever sensor it could be, we are categorizing them into these 5 major areas. One is your motion, the other one is optical sensor, third is biometric, fourth comes in the environmental sensor, and fifth in the acoustic sensors, right? So we will see how or what are the parameters that are being mentioned with these sensors and sensing applications or else, and what sensors we really use for this purpose. So the first thing that comes here is the motion sensors. So when it comes to motion sensors, what it detects the motion. And when we say about motion, what motion it detects? Is it just a walking something like that, walking of a person or no? No, it complete changes. The general sensors that are being used for this purpose are accelerometer and gyroscope. These sensors were earlier used with the flights as well as aircraft as well as ships, right? Wherein now these sensors find their applications in most of the areas. Say even in the cars which we drive every day, we have the sensors now, and the application has been extended or expanded to every area. So that is why this comes in the first point. The second is optical sensor. When it comes for optical sensor, it is light detection and ranging is the function of the optical sensors. Okay, what are the sensors that comes under this particular criteria is your LIDAR and then radars. The third one is ultrasonics. Of course, ultrasonics is used for ranging. Doesn't come under light, but for the purpose of detecting the ranging, we use ultrasonic sensors. Then the biometric sensors. Biometric sensors include facial recognition, fingerprint reader, and the thermal readers, right? Thermal readers here specifies the smartwatches and other things where it detects your temperature, bodily temperature, and other things. That is what is the thermal reader here means by. And general sensors which we use here is the fingerprint, iris, and then ECG. These are the 3 primarily used biometric sensors. Then comes your environmental sensors. And what are the parameters that are going to be read by this environmental sensors? The common thing is pressure, temperature, of course, humidity is also there, and the chemical composition or chemicals. Why or what the chemicals means by is that your pollution part, the air pollution and all those things are there. Now, gas sensors are being used in this case. So here comes the temperature sensor, the humidity sensor, and the gas sensor. These are the prime sensors which comes under environmental monitoring, right? And then is the acoustic sensors. When it comes for the acoustic sensors, the prime thing that it senses is sound. Here again, microphones, ultrasonic sensors comes into picture in this areas as well. So this is the general parameters or the general areas which we have, and the sensors that are being used, and the parameters that are being measured. This generalized sensor, the purpose are given here. Followed by that, let us see what are the application areas of these sensors are concerned. The earlier what we see was the application of the sensor network enabled with AI. Now we are seeing about the sensors and their specific applications. Right now we are seeing about the sensors and their applications. So first comes the motion sensor. Where are we using these sensors? These motion sensors are generally used in gaming consoles and smartphones. These are all simple level I'm speaking about, because earlier I was telling you even the cars which we have today have these motion sensors, your accelerometer and gyroscopes. The prime area or the simple application is smartphones and gaming consoles. You may ask, what is the purpose of a gyroscope and accelerometer, which basically was used in an aircraft and ships are used in your smartphones? Here you can see the answer is in the very next line, gaming consoles. Now when you play a game in your smartphone, automatically the object, say for example if you consider your temple run or some games where you have your main candidate or the player who's walking in, shooting or jumping, whatever he is doing, the object that inside your application moves with the help of these accelerometers and the gyroscopes. The accelerometer and gyroscopes gives you the XY directions and the magnetic field of your position. So when you move your smartphone, say the sense tilt, or if you just give some hiking, automatically these accelerometers senses the action, and then accordingly that particular object in your application moves. So that is what is the purpose of an accelerometer and a gyroscope in your smartphone, which was actually used for flight dynamics and ship positioning. So that is how we have made these sensors simplified, and that is being placed into our smartphone, which we buy for less than 10,000 rupees. A smartphone costs us 10,000 rupees, but if you try to buy an accelerometer or gyroscope and a connecting device and an interface and an application development, it would cost you somewhere around 50,000 to 1 lakh a minimum, right? Because you have to find the right accelerometer, then you have to find the right interface, and then after that you have to do the programming part, and then you have to develop your UI, user interface, to perform some measurements. But wherein with your smartphone you will be able to easily use that. So that is one another part which we will see in the later slides as well. So then comes your optical sensors. So when it comes for optical sensors, here there are two purposes or two main applications, is security and photography. These are the two areas of your optical sensors. And then third comes your biometric sensors. This area is also again security and healthcare is where your biometric sensors are used. Then the environmental sensors, we use it for your weather monitoring applications and smart homes. The last one is your acoustic sensors. This is used for voice recognition and distance measurement. So these are all some of the important application areas of this sensor. So now, so far we have seen the different applicational areas or the generalized overview of the sensors, AI integrations and applications. And for this purpose, we have categorized the sensors also in different ways. We need some sensors, right? So what are the essential sensors that we will need to do all these functions? Let us see few sensors which we will be needing for performing the tasks which we have been telling earlier. So here are the first 10 sensors. Yes, of course, I have few others as well. First one is a microphone. We know what is a mic. Then a camera or an image sensor, a proximity sensor, ambient light sensor, motion sensor, a gyroscope, an accelerometer, digital compass or magnetometer, magnetic field sensor, Hall sensor, and then also we would require a temperature sensor, a humidity sensor, barometer, battery temperature. Why do we need a battery temperature? Is that we have been speaking about sensor modules and then low power consumption, all those things. So when we do so, we definitely will require a power source, and in most of the cases the power source is gonna be a battery, because we cannot directly feed them with the electric power lines, because we do not know where we will be placing these sensor modules. So for example, in your when it comes for your industry or automation and things like that, it is all fine. But when it comes for your smart city applications, your mobility applications, there definitely we will have a battery bank or battery source from which these sensor modules will be powered. So therefore we require a battery temperature measurement sensor as well. So that is what it is. And moreover, the sensors what we see here or the general sensors what we would require to accomplish all that what we have been saying earlier, right? Followed by that, okay, fine. From the battery sensor, we would require a fingerprint sensor, iris scanner, a pedometer or step counter, heart rate monitor, pulse oximeter, a Geiger counter, and then an NFC, near field communication, infrared blaster, laser, a touch screen, air gesture, 3D air gesture and 3D scanning, global navigation satellite system. So these are some of the sensors, or say for example, if you have these sensors, definitely you will be able to build any of the application which we have been discussing earlier. Say for example, here we have the proximity sensor and then the motion sensors with which you will be able to find or you will be able to analyze the distance between your, when it comes for a mobility application, your vehicle and the other vehicle. So these will help you to detect the range, and then whether you are in the whether you're closer or longer, this sensors will help you to analyze the distance. All right. And then when it comes for your fingerprint scanner, iris scanner, heart rate monitor, pulse oximeters, heart monitor, then your NFC, these things will help you in your medical or healthcare application is concerned. Likewise, the sensors what we have here will help us to build any of the application which we have been discussing earlier. The prime source for building those applications is these sensors. Where can we find this sensor? Does these sensors seem familiar to us? Have we ever come across these sensors in our day-to-day life? Is it possible for us to get these sensors and work with that? That was a question. So I'll just post the question in chat box. Where can we find these sensors in our day-to-day life? Is it possible for us to have these sensors in our day-to-day life, all these sensors or few of these sensors, or do we have to purchase them? I have one answer. Anybody else? TV, smartwatches, mobiles, right? Fan. I see. I don't know that. Fine. So how many of you are attending your program in your mobile phones, planes? We have so many systems where different sensors are being used. Fine. Washing machine. Okay. Thermostat, planes. Okay. So now I have shared a link in the chat, right? So if you can just go there, or also you can try this particular, that's it. You go to your Google Play and then you go to your Play Store. In your app, maybe it could be an iPhone or your Android, everything is okay. So either you can click this link and then you will be taken to that particular page, or in your Play Store you just go to the Play Store and just type as sensors and search. You will find an app. Washing machine, AC. Okay, this is called as a sensor app. So when you type that in your I can't paste it here. Fine, I'll do one thing. I'll just paste it in my PowerPoint so that you will be able to see that. So when you link, or if you go to the Play Store, you will find this particular icon or an app with this. The Play Store will give you this app installed. Fine, that's good. Sensor box, yes, of course. Installed. Nice. Nice, nice, nice. Why I was asking you to do that is that these are the sensors that we have in our smartphones. So now you could imagine simply that these are the sensors which we have in our own smartphones, with which we will be able to develop any application. If you go there, you will all the accelerometers, gyroscope, everything is there. Please open the app and see. So when you open the app, you would get a list of sensors that is there in your mobile phone. Maybe all the sensors which we have listed here are not there in your mobile phone, but wherein definitely you will see an accelerometer, you will find an geomagnetic field, your orientation, gyroscope will be there, a proximity will be there, a gravity sensor will be there, linear acceleration will be there, rotation vector sensor will be there, your step counter, then your battery monitoring things. If you go there, you will know what is the temperature of your battery, what is the voltage, what is the status, whether it is charging, the health of your battery, as well as the type of the battery that is being used in your mobile phone. Not only that, everything, you will also see many other sensors in your mobile phone, especially when it comes for your accelerometer. By just moving your phone to a different directions, you will see the XYZ, the three-dimensional plane changes you will see. Also the magnetic field. The geomagnetic field will tell you what is the magnetic field around you. What is the magnetic field in your x-axis, y-axis, z-axis. You just move it near to your laptop, you can see it will be more higher. If you move it away, you just when you are inside a Wi-Fi field, your magnetic field will be different. The field strength, you can know what is the field that you are in, whether the impact is going to be higher or lower. All these things you can analyze with this. This is an ultimate tool which will tell you the various parameters around us. There are many other tools as well, but this one app will give you the exact details of everything. It gives you all the sensors in your phone. Fine. Next, there would be a question. Fine, now everything is okay. Now we have seen about the different sensors. That is all okay. Earlier we saw about how these can be used for different applications. All these things are fine. Now we also saw some sensors which I myself have in my smartphone. But what is the use of these sensors? How can I myself use it? I know my phone is using these sensors to do all the functions, whatever is required. How can I be able to customize these sensors? I want to customize these sensors. I want to use it for myself. How can I do that? Is it possible for me to control my sensors? Is it possible for me to make a modification with these sensors? That will be the next question that comes to our mind. Is there any ways and means how we can do this? Yes, of course. There is a way how we can control these sensors. Controlling and configuring the sensors in our smartphones. We have something called as MIT app inverter. I hope many of you have heard of this MIT app inverter. So this is just an application development tool. Sorry. For this, of course, you have to go to your computers, probably phones. But wherein, if you go to the, I'll just post that link also in the chat. So this is the page. So this is the page where if you go, you will be able to see how you can use all the sensors. I think I should be sharing the entire screen for you to see this app. So let me stop my presentation for a while and I'll share my entire screen so that you will be able to see this app also. I'll just show you how this app can be used, right?
ये लड़की तेरे दिमाग खराब हो गया वो आ चुका है लिंक जल्दी उठ कब से सोई है 4 बजे से सोई है जल्दी उठ 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 भाग
Right.
Sorry for the interruption, sir. You can
No
continue.
problem, sir. No problem, sir. That's fine, sir. So now I am sharing my entire screen. I'll just go to the page. Sorry. So this is the
Sandosh sir, kindly unmute your mic, sir, please.
sir. Yeah. I hope now I'm audible.
Yeah, right now you are audible, sir. Thank
Yeah. So thing is that this is again a completely free page or a free application where you can develop your own Android iOS applications, right? So now you may ask, sir, what is the use of me developing an application? Here I'll show you what is the use. So when you create a login and when you move in, this is the first screen that you will get. In this, to your left side, if you see the user interface and then layout, media, and then drawing animation, lot of things are there with which you will be able to develop your application. And when you scroll down or move down, you will see a tab called as sensors. When you click on that, you can see the accelerometer, the barcode scanner, barometer, clock, gyroscope sensor, then hydrometer, whatnot. All the sensors whichever you have been seeing in your mobile phone, they have them here. What does that mean? Which means you will be able to use these sensors here, right? So here you can see this is your okay. Okay, fine. So here, this is the screen generally, and in the left hand side, you can see what are all the parameters or the sensors you have here. Simply, you can move these sensors, whatever sensor you want, you just move it here or to the screen probably. So you will see that comes here. After this, you can have the layout, you can do all the user interfaces here. You can place these sensors. So when I click a button, what should happen? Here you can change the text of the button. Say, for example, I'll just rename accelerometer control. I'll just have it as axle control. Done. So now, sorry. Now with this, I will be able to do whatever programs I want. In the sense, I can create my own, what to say, see, there are some different things that can be used, data science. Everything is right here. With this, if I want to do any function, I can do the programming here. There is no problem in doing, there is no, what is this? There is no restriction in doing any program that what you want to do with this accelerometer. Not only with the accelerometer, all your sensors can be used right here. So you may ask, sir, everything is fine. I have created a login, but I don't know how to program it. I can see all the parameters are there. That is fine. But this is very much new. How can I do programming? The same application or the same page offers you a step-by-step guide. So I'll just share you that link as well. You need not go and search it for it anywhere else. So here it goes. Like virtual instrumentation. No, virtual instrumentation is like you can do only virtually, but wherein with this app inverter, I have now given you a link wherein if you go, it will say you the step-by-step guide of using this particular, I'll just step-by-step procedure of how to create an application, everything. So once when you complete an application, you will have, like just now you installed the application, right? Sensors. Like that, you will have your own application, which you can download it to your Android phone and or your iOS. The app which you are creating, if you are creating it for iOS, then it will be for iOS. If you are creating it for Android, it will be for Android. Both the things are possible. It will be an app. that can be installed in any Android, not only in your Android phone. Any Android phone you can install it, or any iOS, any smartphone. I'll just make it simple. Any smartphone you can install that particular app, and you can do whatever function you want. So if you are trying to do anything for any of the application area which we have been saying earlier, say it could be an industrial automation, or it could be an smart city program, or it could be your house automation, whatever you want with a smartphone, you will be able to do that. Of course, you will need a smartphone. There is no doubt in it. But you may ask, sir, how is it possible for me to always keep my smartphone for doing this? It's simple. Every now and then, nowadays, we are upgrading our mobile phone. Generally, for less than 2 years, 3 years, 2 3 years, 2 3 years minimum, we just anyhow we will change it. So when we upgrade our mobile phone, so what we generally do is that we just give it back and then go for another new mobile, for which we will get maybe a 50% or less than what we have invested earlier. But for that 50%, when you have a possibility of developing these many applications, why should you go for buyback? Or else, let me even put it simple. Now we have smartphones which are for even 10,000 rupees. We can buy a very good smartphone with a high quality camera, and whatever smartphone you buy, irrespective of their camera, irrespective of their display features, the sensors what we have mentioned are going to be common. Say for example, now I have told you this particular app, maybe tomorrow when you go back to your college or wherever you work with, you just ask your friends to install whichever mobile phone they have, right? If you see, the camera clarity and other things will be different for each and every phone, but wherein these particular generalized apps which we use or which we can use for scientific applications are going to remain the same. These sensors are going to be there in all of their mobile phones, and therefore this can be used for anything. Now we need not go anywhere. When you want to develop your own when you want to develop your own IDEs, when you want to develop your own applications, when you want to do something smart, you need not ask anybody. You need not go for purchase of any sensor. You need not go for any purchase of other controllers. Which controller I should go? Whether I should go for an Arduino or should I go for an what is that? There are a lot of controllers. Like I'm not getting things into my mind right now. There are a lot of controllers, higher end controllers, and all those things are there in the market. You have to buy them, then you have to interface it. We need not do all those things, because we are very much aware that our mobile phones are minimum quad core processors are there, so which are capable of doing multiple things. We have an inbuilt memory of 8 GB and a minimum of 32 GB storage devices there. So even if you develop an app and use your own mobile phone for data collection, these sensors and with the 32 GB of RAM, you will be able to get, as I was telling you about the climate monitoring, with your mobile phone, with the 32 GB of data minimum space I'm speaking about, with that and your RAM what you have and the battery which you have in your mobile phone will enable you to collect data for a minimum period of 3 to 6 months. Minimum period of 3 to 6 months, you can collect the environmental data with all the sensors you have in your smartphone and with your own mobile. Nothing else is required, right? So this will help you to develop a simple smart city app or something else like that. For that, you can simply go learn how to use this MIT app inverter. This is available online for free. You can use this app. Anybody can create a login, and there are a lot of you can see here in this particular page how to do any tutorial. Everything is there. All these things are here. You can learn from here, and you can develop your own system. That is one big advantage of going for this, right? And then comes, let me go to the presentation, and then it is fine. Now, okay, now I have done my I have just started to create my own application. I have developed my app, MIT app inverter. Based on MIT app inverter, I have developed my own application. I have tested the data. I have collected the data. Now I would like to move to the next level of this application. So what is the next level of application? Expanding my project or expanding my contribution. When it comes for such a case, we have something called as Arduino Cloud, right? So this is, again, we have one more thing also. We have Autodesk Tinkercad, with which you will be able to, which will have the basic sensors. I think everybody, most of you will be aware of that. So this is a Tinkercad wherein you will have most of the time you will have all the designs, you will have tutorials. In here you can develop your own systems. I'll just go to the design circuits. When you go to this, you can create a new circuit. I'll just go for a circuit. Again, here you can see all the basic sensors will be there. From this, you can develop your own application, and then you can develop an Arduino circuit. Probably most of you will be exposed to this, and you would have already explored it. I'm not talking about this particular platform. I am talking about another IoT platform, which is Arduino Cloud. Here it is. This is the Arduino Cloud. I'll just this is the Arduino Cloud page. I'll even share just this particular link with you so that you can go there and see what it is. So this is for your Arduino Cloud, right? What can we do in this Arduino Cloud? This is the next level of the Tinkercad platform. So be able to do the basic things. You will be able to learn how to use, how to program, wherein this Arduino Cloud is completely for your IoT projects. So like we have been using your MIT app and all those things now. So the next comes here. This particular platform will help you to get into the next level of project. Say here you will have your own cloud space. You can have your own cloud space. Just go to that page. So here you can have your own cloud space. You will have the sensors. There is virtual sensors here. This is a complete virtual platform, but the data which is being collected here is not virtual. Why? Because once when you develop the virtual sensor module here, you can configure a real-time sensor with your Arduino or some other controller, and then you can connect it with this Arduino Cloud page. What happens is that whatever data is being acquired there will be stored in your cloud page. So in the Arduino Cloud, and this is useful for all your IoT projects, whatever you want to do. And then here you also have the features of embedding the AI part as well. And also regarding the MIT app inverter, I forgot to tell you about. Here also this MIT app inverter, now it is compatible with the artificial intelligence platform. So this can help you to create your own AI platform wherein you will be able to configure your own configure your own application as well with the sensors what we have in our mobile phone. That is what is the prime objective of me telling you this. All right. So the next platform is this Arduino Cloud, with which again you can take your first level of the work to the next level, and you can progress further. All right. And then Tinkercad, I was telling you earlier, you can always learn the basics from here. Speaking about all these things in general, what are the actual challenges and future trends which we will be having with these sensors and all other things? Because when we are speaking about this now, I hope everybody realizes how many sensors we have in our smartphones, which means we have a numerous number of sensor networks already with us. Apart from this also, now we are creating many sensor networks for different projects as well. So with increased number of sensor networks and other things, what are the challenges we are going to have? So here, data accuracy and noise reduction. What is this data accuracy and noise reduction? As I told you, multiple sensor networks are there. So which sensor or which sensor network is giving the actual data? From where should I be reading the correct data? And when you have multiple data, it is going to be a noise, right? If one speaks, it's voice. If multiple people speaks, it's a noise. We are very much aware of that. In the same way, when one sensor sends some data, that is fine. When the second sensor sends the data, it already becomes two sensors sending data. If both the data are same, that is fine. But because of the reliability issue, there could be some nanometer or milli value changes. Similarly, when you have hundreds and thousands of sensors sending the same kind of data for the same time, then it is going to be a noise, which is going to be the correct data you are going to record with. So there we will have the complexity of determining the data accuracy and then noise reduction. And then again, the next part is energy efficiency. We would require low power sensors and also energy harvesting sensors, which can develop their own energy so that you consume less from the sources or your battery backups. Then edge AI and on-device processing. This is the next step what we will have. So this is AI being embedded directly into the systems for faster and more efficient decision making. This is what I was telling you about earlier. AI, that is Industry 5.0 is all your edge AI and on-device programming. And then integration with 6G and IoT. 6G and IoT, yes, of course, because this is all the future trends we are speaking about. So again, we know that now already we are in 5G, the next system is 6G. So now whatever sensors we develop, we are very much aware. The cellular phones came into existence in 2000, early 2000s, which become common to a common man. In 25 years, now we are already in 5G. And after the introduction of 4G, 3G, 4G came very quick, and after 4G, 5G also came very quick. Similarly, our technology in this generations, that is the communication is keep on moving faster and faster and faster. So now whenever you use or you define something or you invent something, this should be capable of the technology compatibility with the near future as well. So that is one big challenge we have, because whatever we have been using in 3G, when 3G came, we have to go for a 3G phone. Then when 4G came, we have to go for a 4G phone. Now 5G, we have to go for a 5G phone. When 6G comes, we have to shift to a 6G phone. So now with this 6G phone, we will not be able to use our 2G or 3G SIM cards and all other things. So what happens? Your electronic waste, e-waste, is accumulating to a greater extent, which is also not good for the environment and all other things. And what are you going to do with all these sensors? These are all numerous sensors. So those are all some of the important things which we have to consider. Finally, coming to the last part of the discussion, the conclusion of what we are trying to do, right? So in the era of AI era, sensors are fundamental for enabling intelligence system across industries. True point. Their integration with AI is revolutionizing fields like healthcare, smart cities, industrial automation, and autonomous mobility. As a sensor technology advances, AI-powered solution will become more efficient, sustainable, and responsive to the world challenges. This is also true. This is the conclusion of the presentation of today. And also, we have seen different things today with which we ourselves can utilize the sensors which we have with us. In this, I have not included your smartwatches, where you have more number of health monitoring sensors, right? There are more number of health monitoring sensors in your smartphones, smartwatches, which I have not given here, but wherein all the functions, that is most of the functions your smartwatches are doing, can be done with your smartphones itself. That you could have understood with the list of sensors which I have shown earlier. And also this MIT app inverter, if you see, there is a list of sensors. From there also you can identify that there are a lot of things that can be done with what you have. So my suggestion would be, try to use that, try to build your own applications, try to build your own AI systems, try to contribute yourself. So that is where we come to the sustainable goal, responsible production. So we have to be responsible in consumption as well as production. So the responsible consumption and production starts from individual, from which we can move towards attaining all other goals. And if you remember the sustainable development goals, there are 17 goals, 1 to 17. If you remember the video, it starts with 17. That is everybody coming together. That is partnership goals. Everybody has to come together to achieve all the goals. That is where it starts. From there, by eliminating one after the other, it reaches the final goal. That is the first goal of no poverty. So the no poverty goal can be achieved with all the smart cities, smart things, everything. All these comes into picture, but it should start with cooperation. That is the joint collaborations, or what to say. So it starts with responsible consumption and partnership things. So everybody has to involve and evolve. Thank you for the opportunity. So I conclude my presentation here, and the session is open for questions. If you have any questions, feel free to ask.
Thank you very much, sir. Thank you for sharing your valuable time with us. Participants, do you have any queries? Please type it in the chat box.
So I'll just do one thing. I'll just also post the sustainable goals, 17 goals. Link in the chat. Accuracy about of the sensors used in the mobile phone. So the accuracy of the sensors used in mobile phone, when it comes for the part of accuracy, it depends on the mobile phone. Each and every phone has a different accuracy levels. But to start with, to begin with, instead of going for buying some sensors and then making your own system, we can develop the system with what we have. And then maybe once when we are comfortable, when we have some data and things, then we can validate it with the real time or some higher end sensors, industry based sensors, that can be done later. But to start with, to develop applications, we need not wait for what sensor should I buy, how to interface, what programming language I should know. Instead of putting our mind into all those things, now we have a simplified solution of different sensors with ourselves, and also a solution to program them to our requirement, with which we can develop our own applications. So this will be the start. So when we start this, automatically we know that all the Android applications, most of them are all open source. So people will collaborate automatically. Your particular app, when you develop and launch it, it will automatically grow itself. It will develop itself. So when it comes to that particular level, automatically the sensors in the mobile phones will also become more accurate. Because it's all about the softwares. It's not only about the hardware. Any hardware can be tuned based on the software. So similar to our cameras. Even though if we have a 64 megapixel camera or 128 megapixel camera, everybody uses some other apps like some Glam app or some Beautify. Some apps are being used. Even the 128 megapixel camera can be enhanced with that particular app. In the same way, whatever sensor you have in your mobile phone, they can be properly tuned and enhanced with some kind of applications which will be developed. Is there any type of limitations in the sensors? So when it comes to the limitations, say we should first start using these sensors. Only then we will be able to know the maximum range up to which we can use it. Is there any limitations or not? I don't think so there will be any limitations, because when you play a game in your mobile phone nowadays, people are playing literally for more than 10 hours per day. So all the 10 hours they play, for example, I'm saying, even though they play for a 10 hours, the gyroscope, the accelerometer, they are working perfectly. And when it comes for gaming console, even more, they are very much accurate. Thank you, sir. Thank you. Ravindra sir, thank you. What is the maximum cost of these sensors? So you would like to know the cost, maximum cost. You should go for the minimum cost, madam, because any sensor, if you take, you have these number of sensors. I recommend you to go and see for each and every sensors. I definitely tell you that for a cost of for which you buy a mobile phone, you will not be able to buy all these sensors. You will not be able to buy all these sensors for the cost. For example, say you can buy a mobile phone for 10,000, which are all these sensors. But for 10,000, you will not be able to buy all these sensors in the market. And even though when you buy the communication protocols, and then you have to go, you will not be able to buy. That is the first point. And the second point is that after that, you have to look for the integration part, and a lot many things are there. So it is not feasible. Minimum cost, I would say more than 50,000. It will take more than 50,000 for you to buy all these sensors, because generally these sensors are all of industrial grade when you go out in the market. So we don't have that much sensor technology which has brought down the cost. May try to get accelerometer cost for you. Cost.
Okay, sir. Thank you very much for your valuable time sharing with us. So another one person asking, sir, please describe the gyroscope working principle.
Sir,
It's the basic question, so we can deal with it. So anyway,
of course.
thank you for your valuable time sharing with us. Tomorrow also, Dr. Sandosh Paramasim sir will come for another one session for us. So let us ask if any doubts, he will answer on that session. So thank you, sir. Thank you very much. Once again,
Thank you,
thank
sir.
you very
Thank you
much
for the
for your
opportunity, sir.
valuable presentation and sharing very ideas for variable review ideas for us. Thank you, sir. Thank you very much.
Thank you, sir. Thank you, sir. Thank you very much. Thank you for the opportunity. Thank you, everyone. See you all tomorrow on the next session.
So let me start the second session. So I want to introduce the resource person, Dr. Alvin Gladson. He completed his BE in the year of 2003 from National Engineering College, Koilpatti, and ME in 2005 in CAT camp in MEFCO College of Engineering in Tamil Nadu. He completed his PhD in the year of 2020 in Anna University, Chennai. He is having 18 years of teaching experience. Currently, he is a professor of Mechanical Department in SCAT College of Engineering and Technology, Sairan Mahadevi, Tirunelveli. He published more than 30 research papers in reputed journals. With 5 patents he also published. So I welcome Dr. Alvin Kingsley, and I hand over the session to Dr. Alvin Kingsley.
Sir, is this visible?
Yes, sir, it's visible, sir.
Am I audible?
Yeah, you're right, audible, sir.
Okay. Welcome, dear participants, for the ASTA ATAL Faculty Development Program on sensors and their applications. Today, I want to give some outline about the sensor used in aerospace and automotive applications. Regarding the aircraft, in modern aircraft is consists of multidisciplinary engineering fields. It consists of aerospace, radio frequency, computer science, electrical electronics, mechanical, electromechanical, and mechatronic system. The main thing happens with the aircraft is its maintenance and its health monitoring. It will be only done by the help of the smart sensors only. What are the challenges we faced in maintenance of the aircraft is aircraft will operate 24/7, make the maintenance very complex, and at the same time commercial aircraft travel very long distances, very tight schedule, daily with very tight schedule, therefore very less time for maintenance. Then military aircraft undergo continuous operation in war fields and in training sessions, therefore in conducting maintenance in war field and the training sessions is also very much it is not possible, and poor maintenance will absolutely lead to the risk in the human lives. The current maintenance approach is based on the aircraft performance. Aircraft performance means while the aircraft performance is decreasing, then only they go for the maintenance. But this type of maintenance will cost the lives of the many peoples. This is called as breakdown maintenance. It leads to higher cost. The preventive maintenance only we can, without any disturbance or without any failure of the human lives and without any failure of the components, we can carry out the aircraft. Okay, the role of embedded and smart sensors in aircraft maintenance is it enables real-time health monitoring of the aircraft components, because it gives the real-time data, whether the data means the parameter of the particular component is going as per the standards. It is working, whether it is working normally or abnormally. So it enables the real-time health monitoring of the aircraft components. It detects issues before the failure occurs. When the parameter goes beyond the normal range, we can able to sense that it is going to fail. We can definitely go to the preventive maintenance. So it supports proactive maintenance, that is called as preventive maintenance. It reduces breakdowns and improving the safety of the aircraft. The main objective of using the smart sensors in the aircraft is continuous monitoring and preventive action to improve the aircraft reliability and the efficiency. Composite materials. Composite material means most of the aircraft is made up of the composite materials. Composite material is a combination of two or more materials. It is produced by layer fabrication methods. So the embedded sensor is very much useful in composite material aircraft structures, because we can integrate the sensors in any part of the aircraft component. The popular sensors are MEMS based, microelectronic mechanical system based sensors, and the fiber optic sensors. The MEMS based sensor is very compact, that is less in size and efficient for various applications in the aircraft structures. And fiber optic sensors, it is multiplexing, that is we can from single fiber optic we can use the multiple sensors, and due to this multiple sensor usability we can gain high accuracy and the durability. The recent advancement in embedded sensors are wireless sensor networks and fiber Bragg grating sensors. The wireless sensor networks allow real-time monitoring without any physical connections. Without any wired connections, we can get the real-time monitoring. In the case of fiber Bragg grating sensor, it is highly preferred due to their precision and ability to detect the dimensional changes in the aircraft structures, because the dimensional changes in the aircraft structures, it leads to deformation, which leads to failure. It is very much important in monitoring the aircraft structures. Different types of sensors we are used for embedding. Each one is having its unique advantages in monitoring the health of the aircraft structure. First one is the MEMS-based thin film sensor embedding. It is a small piezoelectric sensor. It is embedded just beneath the surface of the aircraft structure to monitor the interface loads in tooling workpieces. That is minimal disturbances to the surface, and the and it is there is no disturbance on the any surface. Beneath the surface only we are embedded this piezoelectric sensor. Therefore it will monitor the load, air load or any load which will act on the structures. The factors which affect the sensor output are the depth of the sensor below the surface, and the distance between the load and the sensor, and the spacing between the multiple sensor. How much distance the sensor is located below the surface, then the distance between the load of act and the sensor, and the distance between the multiple sensor. The use of embedded sensor in structure is which helps in damage detection and the physical model, mathematical model validation. Because using the mathematical model validation, we can detect which part is going to get failure, which part is getting damaged. Okay, provides not only we can detect, and also it provides continuous monitoring by this embedded sensor. It includes accelerometers, PVDF film sensors, strain gauges, piezoceramic patches, and optical fiber sensors. Smart structures. These smart structures, these embedded sensors in the sensors embedded in structures is called smart structures. It is embedded with multiple sensors for real-time monitoring. It validates the mathematical model of the structure using the hypothesis testing. The next one is shape memory alive for the health monitoring. It is to detect the crack growth in the structure. But the composite material, since it is made by layer, we have used the sensor to find out the growth of the crack, the initiation of the crack, and as well as the growth of the crack. It is used for this SMA. This SMA file sensor tested for monitoring the damage in the composite carbon fiber reinforced polymer laminates. This is one type of the composite material. This shape memory file sensor, it is used for monitoring this particular type of composite material structures, that is carbon fiber reinforced plate laminate. Then MEMS-based strain sensor. It is MEMS-based strain sensors. It is fabricated for fiber reinforced laminated composite plates. That is this sensor is used for this type of fiber reinforced laminated composite plates. It is used for tested under the response of the and uniaxial tension and the bending loads of the composite plates. If the structure is undergoing any uniaxial tension or bending loads, this type of sensor can be used for monitoring the health. 3 design of strain sensors are evaluated. One is piezo-resistive filament directly fabricated on a wafer. The second one is rectangular cantilever beam, and the third one is curved cantilever beam. These test results were done for 10,000 cycles of uniaxial tension. All designs shows this piezo-resistive filament, this rectangular cantilever beam, and the curved beam. All designs showed reliable and repeatable good performance. Then wireless sensor embedding. This purpose of wireless sensor is to overcome the wired sensor challenges in the composite structures. The wired sensor means it will if the structures get damaged, this wire is also get damaged. We cannot get the real-time information. So in order to get the real-time information without the help of the wire sensor, we can using the wireless sensor. This eliminate the physical connection while maintaining the data transmission capabilities as much as the wired sensor. This development of wireless sensor was started in 1997. It utilized the micro machine sensors and also the remote query devices for wireless communications. These remote query devices was used for getting the information from the required area, required parts or components of the aircraft. This current research is focused on developing an embeddable antenna for both receiving and transmitting the data. The next advancement in wireless sensing network is to measure the strain in the composites. Strain is nothing but deformation. Deformation is nothing but change in the dimension of the components. It is very much the change. If the dimension of the component is changing, means it is the failure is changing to the failure is going to happen in the component. So the MEMS-based wireless sensor was developed. That is, wireless sensor was developed to measure the strain. The sensor included 3 types of components. One is driving element, one is sensing element, another one is telemetry circuit, which is fabricated on a single silicon wafer. The next one is finite element method. This ANSYS analysis method were used to analyze different designs before manufacturing. Before manufacturing this wireless-based sensor, we are using the finite methods to analyze the different designs and the different designs in the particular component of the aircraft. Then various studies on the intelligent wireless sensing was going on. Because the intelligent sensing and the wireless communication in extreme harsh environment and as well as in harsh environment, in the hard to reach environment is very much needed. In case of the aircraft maintenance and the health monitoring. It is focused on the performance testing of the inertial sensors of the MEMS. It explored battery-free embedded sensor for use in the weapons. Battery-free sensor means for energy, for electrical power source for the sensor. We can without any battery, we can use the sensor in the weapons and the military operations, and also in the military aircrafts. These features of the embedded wireless telemetry is it allows wireless stress-free communication between the sensors and the central processing units. It integrated with smart materials and electronics for real-time data exchange. Smart materials and the electronic system for the exchange of the real-time data. The research still continues on integrating smart sensors, actuators, and control systems into an embedded telemetry system. The next one is fiber optic sensor. Fiber optic sensor is a leading technology, sensor technology used in the structural composites. It is referred to as fiber optic small structures. More than 2 decades, many research is going on its applications and improvement of its applications. The key features of the fiber optic sensors are it can monitor vital parameters of different structures. It offers lightweight design and resistance to the electromagnetic interference. It offers a very lightweight design as well as it cannot affected by the electromagnetic interference. It can function in the harsh environment, weather conditions, climate conditions without being get damaged. It provides non-intrusive embedding and high bandwidth capability. The main advantage is high bandwidth capability and the resistance to the electromagnetic interference. The next one is its function is it enables the real-time health monitoring of the structure. It is embedded during the manufacturing or applied when during the operation. It can be embedded during the manufacture as well as during the operation. It works similar to the human sensors like hearing, seeing, smell, taste, and touch to detect the structural conditions. All the 5 sensors we can use to detect the structural conditions of the aircraft. It provides very instant data on the health, ensuring the early detection of the damage. Because instant data help us to detect the nanosecond response recording of the data will help us to detect the damage or failure in as early as possible. Then fiber optic sensor disadvantages is it is high fabrication cost, make them expensive to implement. Very fragile in nature makes them prone to damage. Due to fragile nature, it also when exposure to any harsh unit, it will get damaged. So it will be embedded or it will be safely placed in the aircraft structure. It requires special provisions for ingress and egress within the structures, and its applications to detect the structural changes in composite materials. It applied in aircraft structure to analyze low velocity impacts on the composite layers. Not only high velocity, it is analyze the low velocity impacts on the composite layers. These are the various parts of the aircraft and these sensors. The circular dot shows the sensor in the various parts of the aircraft. The tail plane, rudder, elevators, trailing edge flaps, leading edge flaps, rudder pedal sensors, the pilot stick sensors, then nose wheel steering, and the spoilers and the ailerons. These are the major airspeed sensor. It is used to calculate the airspeed around the atmosphere of the aircraft. The magnetic compass, this sensor is used to find out the directions, and the GPS to find out the locations of the nearby aircraft and also the base aircraft. The radio compass, the altitude sensor. This sensor used to determine the height of the aircraft. Barometer pressure sensor. It is used to find the pressure in the engine as well as in the cabin as well as in the pilot cockpit as well as in the fuel tank pressure. Then outside air temperature sensor, then cabin air pressure sensor, cargo, that is cargo air pressure sensor means in cargo area, all doors and bulkheads have sensor to calculate this air pressure inside the cargo area. Then cabin temperature sensor, All doors of the cabin have these temperature sensors. Then also cargo temperature sensor, fuel temperature and fuel tanks and fuel pump sensor is very much needed to calculate the flow of fuel flow into the engine and how much remaining fuel is we are having. Like this, fuel sensor is very much needed for the aircraft. Then hydraulic pressure, it is spoilers, rudder, landing gear, pump. These all have the hydraulic pressure sensors, weight sensors. It will be placed in the landing gear to correctly place the landing gear on the land to carry over the whole weight of the aircraft correctly through this landing gear. Fuel pressure sensor is located in the engine. Fuel flow sensor is also located in the engine. Turbine, the inlet turbine temperature, outlet turbine temperature, and its inlet turbine pressure. Then voltmeter, it is for cockpit, main bus, cabin, auxiliary power for the power unit to calculate the power throughout the aircraft. Then generator meters, the auxiliary power, there is a separate engine. Apart from the main engine, there is a separate engine for the aircraft. For that, this generator meters is sensor is needed. Then electricity load sensor is also used for the aircraft. Why the embedded sensors? It is need for aircraft. It's need for health monitoring. Embedded sensor need for health monitoring. The aircraft structures and its subsystem requires regular and planned maintenance. Harsh operation conditions make the structural get damaged. So the structural health monitoring reduce the maintenance cost. How it reduce the maintenance cost means we can real-time data of the structural health is if we get the real-time data on the structural health, it will actually reduce the maintenance costs and ensure safety and reliability. The most research and development is focusing on optimal methods for aircraft health monitoring and smart embedded sensors for early detection of the failure, and these sensors can predict and identify the problems in critical aircraft components, mainly engine and the pressure inside the cargo and the cabin area. Then working of the aircraft. Aircraft flies due to the lift force. The lift force is created by the pressure difference between the upper and the lower wing surfaces. Air sticking to the wing due to air viscosity can reduce the lift force. The angle of attack. The angle of attack means the angle between the wing and the airflow direction affects the lift. Once again, the aircraft flies due to the lift force. The lift force is created by the pressure differences between the upper and the lower wing surfaces. Air sticking to the wing due to the air viscosity can reduce the lift force also. The angle of attack affects the lift. The next one is flow separation. The embedded sensor for aircraft flow control. Flow control. At low speeds and high angle of attack, air separates from the wing, reducing the lift. At very low speed, if the angle of contact very low at low speed and the angle of attack is very high, then air separates from the wing and reducing the lift. This unsteady airflow during the maneuvers can cause early flow separation, leading to the loss of the lift. So the flow separation affects the aircraft performance. Flow separation affects the aircraft performance and safety, make it essential to predict and detect. So this flow separation, we have to, whether it is the correct flow separation is happening at the wing to lift the aircraft or not, we have to early you detect this flow separation effect. This monitoring flow separation with these sensors. This network-based pressure sensors on the wing. The wing is embedded with the network-based pressure sensor. It measures the pressure fluctuations to detect the flow separation. These pressure variations are analyzed using the root mean square value of the signals from this sensor. The sensor will give some data. The root mean square of the value gives the pressure variations. These signals increasing laminar separation bubbles and decreases after the reattachment. First, initially it is increases, and after detachment it will be decreases. Then embedded sensor for the aircraft flow control. That is for the aircraft flow control. Experiment setup using the ATR 72 aircraft. It is a twin-engine regional airliner. It is used for testing the airflow over the wings. CFD, computational fluid dynamics simulations, help determine optimum sensor placement. This CFD is used to find the simulation. This fluid dynamics simulation is used on which area of the wing we have to place the sensor to get the correct data of the flow separation data. Results were validated using the airfoil, this standard airfoil cross section, a standard aircraft wing design. Then capacity-based pressure sensor design. It is used for the aircraft flow control. Capacity-based pressure sensor design. This capacity-based pressure sensor is this capacity based pressure sensors were chosen for the very low cost and the large coverage area coverage. The sensor design used a deformable membrane and a moving electrode on a copper clad polyimide layer. In the sensor is used a deformable membrane and a movable electrode. With this, both membrane and the electrode are placed on a copper clad polyamide layer. These final element method simulations were used to analyze sensor deflection and the stress distribution. The same FEM simulations were used to analyze the sensor deflection as well as the stress distribution. Then data collection and the analysis. Data collection and the analysis. Sensors were networked and data was collected on a central computer system. Pressure variations were observed at different angle of attacks between the airflow and the wing structure. With the pressure variations, the angle of attack between the 4 degree to 18 degree, and the pressure changes were also recorded for different sensor positions from 0 to 0.14 meter. Then traditional aircraft health monitoring methods, that is, it used traditional health monitoring methods of the aircraft wings. It is based on ultrasonic wave and eddy current technology is used for the aircraft health checks. This method scan point by point, making the process time consuming. One point at a time, the next point, the next point, the next point on the wing. That is time consuming process and the labor intensive. Some interior parts must be removed for inspection, and adding some interior parts must be removed for inspecting these aircraft. Some interior parts of the wings also removed, this adding complex to the aircraft monitoring method. Then advantages of the in situ monitoring system. The in situ monitoring system means inbuilt sensor on the wing. It is faster and more efficient than the traditional methods. It can scan large area at once. It provides real-time information about the defect type, location, severity, and the possible solutions. It provides real-time information about the what type of defect is in the wing and where it is location and how severity it is, and the possible way of solution also it will suggest based on the data available from the sensor. It uses wireless communication to send health data to the operators in the land. It uses also the ultrasonic aircraft wings health monitoring using the embedded piezoelectric sensors. This piezoelectric sensor using ultrasonic guided waves. These ultrasonic guided waves propagate in solid structures, useful for non-destructive inspection. The main advantage is very fast scanning of very large areas and long range detection of the damage. It is very low cost and ability to scan ability to scan the human inaccessible areas also. This piezoelectric sensor network for monitoring. The small piezoelectric wafer transducers can be mounted on aircraft structure, or otherwise it is embedded in the aircraft structure. These sensors are guided waves for continuous health monitoring. It is used for crack detection, stress monitoring, and joint inspection in the aircraft. Crack detection means the crack initiation and the growth. Stress, the force acting on the unnecessary forces acting on the wings, and as well as joint of the wings. For inspection of the joint of the wings are also carried out by this piezoelectric sensor. It uses the smart layer technology. It integrates the multiple sensors and actuators in a network-based system. That is this piezoelectric sensor network is used for the monitoring the wings. Studies and experiments were carrying out on the piezoelectric sensor. piezoelectric sensor, that is piezoelectric vapor sensors. When the piezoelectric vapor sensor length matches half the lamp wavelength, maximum signal coupling occurs. When the piezoelectric vapor sensor length matches half of the lamp wavelength, the maximum signal coupling occurs. These guided waves in piezoelectric disc is used to inspect the composite wing joints. Based on this coupling signal, and we can inspect the composite wing joints of the composite wings. The challenges in data processing are it requires better algorithm to reduce the errors and biases in the sensor data. There should be the some biases in the sensor data based on the real-time environment, as well as the location of the sensor in the wings. To reduce these biases and to reduce the error in the data, it requires the better algorithm. And also another challenge, it needs to improve accuracy in detecting the defect location and the level of the severity. Aircraft wing structural study includes these aircraft wings have a complex structure with the ribs, spars, joints, panels, and the stiffeners. They endure high stress, leading to fatigue failures at rivet holes and the stiffener bars. Due to the endurance of the high stress, they are leading to fatigue and failures at the rivet holes and the stiffener points. Some researchers studied fatigue failure in the CFRB and glare and aluminum alloy aircraft structures, the composite material aircraft structures. The experiment was conducted on E2 surveillance aircraft wing. A wing section was cut into pieces for testing. The wing of the E2 surveillance aircraft was cut into pieces for the testing. The angle beam lamp wave transducer were used to analyze the wave propagation and signal effects on the particular portion of the wing. The paint on the wing surface reduced the signal quality. A 1-foot piezoelectric layer was bonded inside the wing for better wave generation and the reception. Wing paint will the surface paint of the wing reduce the signal quality. To overcome this, a 1-foot piezoelectric layer was bonded inside the wing for better wave generation and the receiving of the better wave. Different defects were simulated, that is loose rivet is getting loose to aircraft wings, rivet gets loosened, then cracks in the rivet holes. These are all simulated. Then rapid algorithm for the defect detection. Used piezoelectric disc array data to detect, locate and monitor defect growth. Experiment results show signal attenuation due to the beam broadening and the multiple path effects. We can use the rapid algorithm. It's one type of algorithm for the defect to detect the defect from the sensor data. The experiment results showed the signal attenuation due to the beam broadening and the multi-path effects. Then optical fiber sensors for the aircraft structural health monitoring. The advantages of the optical fiber sensors in aircraft is it is very lightweight, which is very much importance for the aircraft design. It will resistance to the electromagnetic interference, making them highly reliable for the aircraft structure. It is high sensitivity, accuracy, and resolution for detecting the structural issues. It is easily embedded into the composite aircraft structures. It is used for real-time health monitoring, for safety improvement, and for improving the maintenance. These are the advantages of the optical fiber sensors in the aircraft. The three main approaches for the optical sensor deployment in structural health monitoring is single point sensor, distributed sensing, and the quasi-distributed systems. In single point sensors, it detects pressure and temperature in specific area. In distributed sensing, it can collect data from any point along the optical fiber. In quasi-distributed systems, it is used for large structures integrating. It is used for very large structures integrating many single point sensors. These are the three main approaches using in the structural health monitoring using the optical sensor. The next one is sensors in the electric vehicles. Sensors in the electric vehicles. There are battery powered electric vehicles, that is called as electric vehicles, and hybrid electric vehicles, that is more than one source of energy. It is used for drive the vehicle. What are the sensors used in the electric vehicles? Are position sensors, speed sensors, temperature sensors, and pressure sensors. Some electric vehicles use very small engine only to charge the battery. Therefore, it will reduce the number of sensors to be used. Common sensors on electric vehicles are temperature sensor, voltage sensor, and current sensor. Temperature sensor is used to monitor the battery heat as well as the motor heat of the battery and the motor. Voltage sensor is used to measure the battery level, battery power, to measure the power levels of the battery. And the current sensors to track the electrical flow in the system. The additional sensors in electrical vehicles are position sensor. It is called as resolvers. It is used for traction motor load. It will control the motor will be controlled. For this, we can use the position sensors. For example, it is BMW and Volkswagen electric vehicles are used this position sensor. It is expensive mechanical device used in BLD brushless motor control system. Current sensors, minimum 2 or 3 sensors needed for the motor control in the brushless BLDC motors. It is used in the electric vehicle motor controllers. The current sensor used in electric vehicle motor controllers. Transmission and sensor reduction in BEVC, battery powered electric vehicles. Battery powered electric vehicles require fewer gears, reducing the complexity of the transmission. It reduces the transmission complexity very low. Only 1 or 2 positions are needed for this battery powered electric vehicle. Fewer additional sensors are compared to hybrid electric vehicles, leading to simpler system architecture in the electric vehicle. Position sensors in the automotive sensor. What is the purpose of position sensors in the automotive sensor? It is used to measure the angular motion, mechanical angular motion, measure the mechanical angular motion and convert into the electrical signals. It is designed to work in harsh environmental conditions found in automotive systems. Based on the electrical signals, the position of the wheel and the motor is determined. Types of position sensors: the rotary position sensors, it is also called as angle sensors. It measures rotational movement accurately. This rotary position sensor measure the rotational movement accurately. The common sensors used for the motor control is resolver. It is used for precise motor position tracking. But what position the motor is now? This precise tracking of the motor, we can use the resolver. The next we use for motor control is the encoder. It converts the motion into the digital signals for the control system. Converts the motion of the motor into digital signals, and it passes the signals to the control system of the motor. Purpose of the then resolver. This is called as analog position sensor. It functions like a small transformer. It will function like a small transformer. It has 3 windings. One is primary winding, which is located on the shaft. The next one is 2 secondary windings that is positioned 90 degrees apart from each other. Its working principle is the analog position sensor. It measures the shaft rotation. It measures the shaft rotation by calculating the turns ratio and polarity between the coils. The polarity between the coils, and by turns ratio, it calculates the shaft rotation. It functions like a rotary transformer. It detects angle variation when this shaft rotates. It uses an AC reference voltage to excite the coils at a constant frequency. The output frequency from the stator and rotor remains the same, but difference in the phase by 90 degrees. It generates sine angle, cosine sine signals and cosine signals, where the voltage depends on the reference voltage and the shaft angle. It functions like a rotary transformer, detecting angle variations when the shaft rotates. It uses AC reference voltage to excite the coil at a constant frequency. The output frequency from the stator as well as from the rotor remains the same, but differs in the phases by the 90 degree. It generates the sine and as well as the cosine signals, where the voltage depends on the reference voltage and the angle of the shaft. Then encoders. It is the motor position sensors. What are the different types of the encoders? First one is absolute position encoder, and the second one is incremental encoder with the reference mark. In the Absolute position encoder, it uses a disk with a specific binary pattern. If it is a 3-bit output, it has 8 pattern position. It is useful when power turns or off intermittently during the operation. During the operation, the powers turn on and off, turns on and off intermittently. Then we can use this absolute position encoder. Then incremental encoder with the reference mark. That is absolute. Previous one is absolute position encoder. This one is incremental encoder with the reference mark. It determines motor position using the binary high and the low, 1 and the 0 signal. If the pulses generated are proportional to the rotational distance, the pulses generated by these encoders, this type of sensors are proportional to the rotation distance. A reference mark is used to indicate the angle 0 in this sensor. The last one is incremental sinusoidal encoder sensor. This is the motor position sensor. It produces sine wave pattern and the cosine wave pattern with the reference mark, 0 mark. It requires electronic circuit to process the signals. Unlike a reservoir, it does not have a carrier frequency. It produces higher frequency signals. It does not have carrier frequency. It produces only higher frequency signals only. The next sensor in electric vehicles is, apart from motor position sensors, the next one is battery monitoring sensors. It is essential for the electric vehicles. It monitors battery health and the state of the charge, the charge level of the charge. It typically used with 12-volt lead acid batteries. The key components of these battery monitoring sensors are analog devices. The second one is shunt resistor. The next one is sensors are placed on the battery module for real-time monitoring. 3 main measurements will be taken with the help of the sensors from the battery. First one is voltage, the second one is current, and the third one is temperature. Voltage, each battery cell has a each battery cell has a voltage measurement chip. Each battery cell has a voltage measurement chip. It is most critical. Next one is the current. That is, the current is measured using the shunt resistors or open loop Hall sensors. Then temperature, it is measured using the NTC thermistors, the non-linear thermistors. Then MEMS technology in automotive vehicles. It is widely used in modern vehicles. The MEMS technology is used in airbags and the vehicle stability control. 4 main types of MEMS-based sensors are: first one is accelerometer, the second one is gyroscope, and the third one is inclinometers, and the fourth one is flow and pressure sensors. What is accelerometer means? It detects the motion and the impact. It detects the movement of the vehicle, detect motion surrounding the vehicle, and it detect the impact of the surrounding body with the vehicle. Then gyroscopes, it measure vehicle rotation and stability. It measure vehicle rotation and stability in the case of turning or in the steep turning, in that the very speed, when the vehicle go very speed at the very curve, it measure the vehicle rotation and the stability. Then inclinometers, it detect tilt and the angle changes in the vehicle. Then flow and pressure sensors, it monitor the fluid movement and the air pressure. Fluid movement in the sense means the fuel flow as well as the brake oil flow as well as the engine oil flow. Then emerging applications are energy harvesters, oscillators, and infrared sensors. Energy harvesters means it converts vibrations into the electrical energy which is required for these sensors. Then oscillators, it improve vehicle timing and performance. Oscillators improve vehicle timing means engine performance as well as the performance of the engine. Infrared sensor, it is used for detection and the safety systems. Next one is MEMS-based sensors for the passenger safety. For when the prevention of the collision, we have to deploy the airbag. For the deployment of the airbag, we use this MEMS-based sensor. It detects rapid changes in the vehicle acceleration, automatically deploy airbags to reduce the impact. Based on the vehicle acceleration, it detects the vehicle acceleration changes in the vehicle acceleration and automatically deploys the airbags to reduce the impact. Then MEMS based accelerometer in airbags. In traditional methods, it uses G switches to activate the airbags, but this MEMS based sensor replaces the G switches. It continuously monitors the vehicle accelerations. The accelerometer continuously monitors the vehicle acceleration. It detects sudden deceleration through capacitance change in the capacitance value. If the capacitance value changes, it detects the sudden change in the deceleration. It sends signal immediately. It sends signal to activate the airbags. Use of the MEMS gyroscope. This MEMS-based sensor used for skidding and rollover reduction. To avoid the rollover of the vehicle, and for the skidding of the vehicle, we use this MEMS-based sensor, MEMS gyroscope. It measures the angular velocity of the wheel. It helps to maintain the vehicle orientation. Vehicle orientation with the surface of the road as well as the wheel of the vehicle. It helps to maintain the vehicle orientation. Working principle, it's based on the conservation of the momentum. This MEMS micro gyroscope is working based on the principle of the conservation of the momentum. It is used in vehicles, commonly used in trucks for rollover reduction, and hence it improves the vehicle stability and the safety. The next MEMS technology used in automotive vehicle is tire pressure sensors. Tire pressure sensors. Its function is to alert driver about the air leaks and underinflation of the tire. It monitors the natural air pressure loss over the time. Not only due to the puncture only the air will leak, also naturally due to the weight of the vehicle, it is moving up and down on the road surfaces, naturally air pressure will leak. So this tire pressure sensor, these also monitor the natural air pressure leakage. These challenges in the older sensors are full package replacement due to the battery life issues. The sensors operated by the battery life. If the battery life get advantages, the whole sensor system must be replaced. This replacement was very expensive. In modern advancement, MEMS-based sensors have gained popularity among the vehicle manufacturers because newer type pressure sensor modules are more compact and battery less. It does not using any battery. It is very less simple in size, very less in size. This MEMS-based energy harvesting technology now used to make this sensor very smaller because the battery is not used. The size is very compact and it will be gaining more popularity nowadays in the tire pressure sensor, this MEMS-based sensor. Then electronic stability control of the vehicles. Why it is important to use the electronic stability control for the vehicles? It helps drivers maintain the stability and control during sudden movement or the jerk. It helps drivers to maintain the stability and control during the sudden movement or the jerk of the vehicle. What technology is used means it uses the MEMS-based gyroscope and accelerometer. The sensor used are MEMS-based gyroscope and accelerometer. It enhances vehicle stability by detecting and responding to sudden changes. It enhances vehicle stability and by detecting and responding to sudden changes. It advantages as improved efficiency, very reduced device size, and cost effective, widely used in modern vehicles. MEMS sensor for in automotive vehicles, another type of sensor for engine management. For engine management, the pressure inside the engine is very much needed to correct combustion for the correct power production. So it is used for the pressure sensing inside the engine and act as an air mass flow sensor. Air and the mass flow. Air means the fluid and the air mixture flow to monitor the fluid and as well as the air flow. So we can use this MEMS sensor. Its application is barometric pressure sensor. It helps adjust the fuel combustion process. It reduces the usage of the fuel for the combustion process and increase the efficiency. Then electronic braking system. It is uses a low G range accelerometer to measure the acceleration. It uses a low G-range accelerometer to measure the acceleration and inclination. It uses a low G-range accelerometer to measure acceleration and inclination for accurate the brake pressure. The components in the electronic braking system is electronic brake module, actuator, and the electric switch. The electronic brake module receives the driver command. The actuator executes the driver command from the brake module, and the electric switch is located in the driver cabin for the driver control. The working principle is the driver sends a command to the electronic brake module. The module forwards the command to the actuator. The actuator applies force on the brake pad. The brake pad presses against the wheels to stop the motion. The sensors for the anti-theft. For anti-theft condition also in automotive vehicle use of the sensor. It prevents vehicle theft by detecting the movement or the tilting. Movement of the tilt by sensing the movement or tilting of the vehicle, we can prevent the vehicle theft. The previous issues, older sensor could not detect the small tilts. When a vehicle was pulled by a rope or chain, when the vehicle is pulled by a rope or chain, the old sensor did not detect the this kind of theft. But current technology MEMS based 3-axis accelerometers. In the current technology, MEMS based 3-axis accelerometers to measure the vehicle's inclination angle related to the earth. It provides better detection and the security against the unauthorized movement. Vehicle navigation based on MEMS, commonly used in most of the vehicles. It is installed in most of the vehicles, especially the commercial ones. The role of GPS. GPS helps in vehicle tracking. GPS signals can be blocked by tall buildings or walls, so we need for the MEMS sensor. This GPS for used in vehicle tracking. The GPS signals can call by tall buildings or walls. Therefore, we need to go for the MEMS sensor. These gyroscopes and accelerometers provide additional data on the position and the movement of the vehicle. It helps in determining the vehicle's forward path. Vehicle navigation based on MEMS. Other applications of the MEMS sensor is headlight leveling, motor damping, fuel line monitoring, fuel evaporation reduction, and the wheel speed measurement. We can use this MEMS sensor. MEMS technologies are used in automotive vehicles. MEMS tiny mechanical and electromechanical elements made using the microfabrication is called as MEMS. Tiny mechanical and electromechanical elements made using the microfabrication. Key components are 4 M's. One is microsensor, another one is micro actuators, third one is microelectronics, and the fourth one is microstructures. The benefits of the MEMS technology is very low cost, high reliability, better performance than the other microscopic sensor. Role in electric vehicles and the hybrid. Role of the MEMS technology in the electric vehicles. It converts the mechanical signals into the electrical signals. It mostly seen in complex sensor integration. Therefore, it is mostly seen in high-end model of the cars only. Future trends of the MEMS sensor will become studied in more EVs and HVs, but that is only used MEMS sensor only. Then battery characterization in electric vehicles. MEMS technology used in automotive in electric vehicles, that is battery characterization in electric vehicles. Why we got to monitor batteries? Charging and discharging causes electrical and mechanical changes in the battery. While charging and discharging, electrical and mechanical changes were happening in the batteries. It prevents, due to these electrical and mechanical changes, the battery will get failure. So to prevent this failure, we are using this MEMS in the battery system, battery monitoring system. Common battery failure causes are malfunction in electronic components, overheating during the charging, and the connector failures. The connector between the malfunction in the electronic components will cause the battery to failure. Overheating during the charging also cause the battery to failure. Then connector between the battery and the power source also make the battery to failure. Recent advancements, ultraviolet based sensors detect electric cars before the failure occurs. Before the failure, electric cars is going to generate the ultraviolet based MEM sensor will detect the electric cars. Therefore, it prevent the damage of the batteries. The next one is piezo-resistive MEM sensor in vehicles. Piezo-resistive MEM sensor in vehicles. It uses to measure the air and the oil pressure in the vehicles. It uses to measure air and oil pressure in vehicles. And it is used in mass production for the automotive applications. Then it is used in fuel cell electric vehicles also. This piezo-resistive MEM sensor is used in fuel cell electric vehicles for detecting leaks in the unit cell. In single unit cell, if it is any leak, we got to detect using this piezo-resistive MEM sensor. How it works means by converting the pressure change into a voltage using a piezo resistor. This piezo resistor will convert the pressure change into the voltage. By this, we can detect the leaks in the unit cell of the battery. Then future of the EVs. EVs is the future market for the conventional vehicles, replacement for the conventional vehicles. They help to reduce the greenhouse gas emission and global warming. Then sensor-based technologies in EVs. Various sensors are used in EVs. Some sensors are also common in conventional vehicles also common. This MEM-based sensor, new micro-fabricated sensors are being developed for electric vehicles. It is used for, first one is for motion sensing. The next one is for battery monitoring. The third one is for energy harvesting. The sensors, MEMS-based sensor used in electric vehicles for motion sensing. The next one is for battery monitoring, and the next one is for energy harvesting. This sensor will reduce the cost, save the space, and improve the sensing capabilities. Then sensors used in automobile manufacturing. An automobile manufacturing shop is called as assembly shop and its sensor integration. Importance of the assembly shop. It converts initially it can only vehicle frame into the final product. Initially the vehicle frame only present. Finally it convert into the final product. One of the most crucial parts of the automobile manufacturing is the assembly shop. The high investment is the high cost investment, high investment in the equipments, because flexible manufacturing system machineries, robots, automation process can be more expensive than the final product. The role of the sensors. The role of the sensor in assembly is it protect equipment from the damage, because it is automation equipment move in precise motion with each other. It should be protect equipment from the damage. It ensures smooth and efficient processing. Smooth and efficient processing for automation, it needs the smooth and the efficient processing. The sensor needs the integration. Assembly shop is integrated with one station is integrated with the another station. One machine is automation machine is integrated with the another machine. So for correct integration, the sensors are used. Smooth and efficient processing. Then maintain high quality standards through the automation. Maintain the high quality standards through the automation. Assembly line is nothing but a production process where manufacturing is divided into number of sub-steps. Each step follows a fixed sequence to ensure the product become a final product. The product moves from one workstation to another workstation for different tasks. So the assembly process, the production process is divided into number of sub-steps. Each steps followed a fixed sequence to ensure the product moves from one workstation to another workstation for different tasks. The benefits of the assembly line. Assembly line benefits is nothing but it enables the mass production. It reduces the labor cost and increases the productivity. So at one point of time, more number of parts can be manufactured, more vehicles can be manufactured. It will reduce the labor cost, because with the same labor we can, using the mass production, we can increase the number of the vehicles and also increase the productivity. Then in assembly line and sensor integration, another one is automation and optimization. This, from one station to our next station, the products or components must be moved. For this we are using the conveyor belts. The conveyor belts reduce the vehicle production time, because for movement of the parts or components from one station to another station, we are using the conveyor belts. Okay, conveyor belts. The process divided into multiple steps for efficiency. Automation reduced health risk. For this movement of the part to the conveyor belts reduce the human usage. Therefore, automation reduced the health risk and improved the productivity of the component. Then role of sensors in the modern assembly lines. It is essential for balancing human and automated system because the assembly line consists of different workstations. The workstation 1, 2, 3, and each workstation there will be the human beings. For that human beings and the machines should be balanced, coordinated equally based on the sensor on the machines. The human must be reactive or perform the operations in the assembly line. It optimizes the material handling and the energy usage. Optimize the material handling means if the one operation is completed, task is completed, the conveyor carrying the component moves to the next workstation. Therefore, the sensor sensors after the completion. This is the sensor location. If the product comes to this, when the operator puts the finished task, after finishing a particular task, if the operator produces in this location, the sensor sends and the conveyor moves to the next workstation. Likewise, it optimizes the material handling, help in fine tuning of the manufacturing process. Fine tuning of the manufacturing process means various operations will be carried out simultaneously on a particular component. Okay, various component means tool. This is first tool, this is second tool, this is third tool. These tools must not interfere each other, must not disturb each other. For this fine tuning of the manufacturing process will help with the help of the sensor we can do it. It improve efficiency and maintain quality control. If it balance human automated system, automatically efficiency is increase. If it optimize the material handling, automatically the efficiency will increase. If it fine tuning the manufacturing process means automatically the quality will improve. The next one is importance of the assembly line. It is very essential for the mass production in the automobile industry. It helps manufacturers cost efficiently by moving through the different process. It reduces the need for the skilled labor. It increases efficiency and reduces the production time. It increases the efficiency and reduces the production time and the cost. Next, role of assembly line. Main sections of the automobile assembly line. First one is body shop, second one is paint shop, third one is assembly shop. In body shop, main vehicle components are manufacturing. It include process like casting, sheet metal work, pressing and welding. In paint shop, components are painted as per the requirements. Then first in body shop, components are manufactured using the manufacturing methods. These are the manufacturing methods. Then paint after the body shop, the parts are manufactured. It is painted in the paint shop, and in assembly shop, final assembly of the vehicle take place. The next one is the assembly line. Types of the lines in the assembly shop. First one is trim line. The second one is chassis line 1. The third one is chassis line 2. The last one is final line. What are the role of sensors in the assembly line? Sensors is used for integrating. It is used for integrating different sub-assemblies. It ensures proper alignment and functionality of the components. It ensures proper alignment and functionality of the components. The proper alignment of the components will be done with the help of the sensors only. If it is properly aligned only, the function of the components will function properly. It reduces defects and dejection in the final inspection. If it is using a sensor-based tightening and nut tightening system, a sensor-based press fitting system, this also in the final inspection, so the number of components rejection will be very less due to this sensor based assembly line system. Next one is first stage, trim line. Trim line in the assembly shop, the first stage. Here vehicle arrives from the paint shop. From the paint shop, vehicle arrives to the trim line. Several sub assemblies like brakes, console box, cabin lamp and door assemblies are prepared here. Key process in the trim line, first process is door disassembly and assembly. Doors are removed and sent to the door module assembly. Electrical components are integrated into the door and movement of the door is restricted within a defined area. Doors are sent to the door module assembly. Electrical components are fixed into the door and movement of the door is restricted in the particular defined area only. Then key process in the streamline is second creeper dashboard installation. Dashboard is selected from the lot and installed in the vehicle. The dashboard is in the storage area, in the nearby storage area. It is selected from the lot and installed in the vehicle. Then windscreen assembly installed using the suction grippers. The windscreen means the front window of the car or any vehicle is installed using the suction gripper. By the vacuum grippers, the windscreen is hold secured and it is fit on the front of the car or vehicle based on the it is located securely located on the proper location with the help of the sensors. The final step, the vehicle moves to the chassis line for the further assembly. The role of the sensor here is most processes are highly automated, requiring high precision. In the assembly line process of the automobile manufacturing, it is highly automated. Highly automated means the machine with various limbs, arms, it's moving precisely. For precise movements, we need these sensors because these precise movements will not affect, we will not collide each other. And at the same time, it should be properly located also. Sensors are integrated with the control system. Sensors are integrated with the control system to ensure smooth manufacturing and the proper assembly. Then code reader in the assembly process. What is the purpose of the code reader? Its main function is used to read coded tags to match the different assemblies of the vehicle. Each sub-assemblies or each component have a different coded tags. You have to read and understand the particular code and the particular component, and we have to ensure the correct placement of that particular component in the sub-assembly in the sub-assembly of the vehicle. Therefore, main function of the code reader is to identify the particular component and correctly placed in the position of the sub-assembly with the help of the sensor. Use of only one-dimensional and two-dimensional tags, it prevents confusion by labeling the components with unique codes. Each and every components have unique codes. By reading that tags, we can identify the components without any confusion. Its working principle is it uses light absorption. It uses the light absorption techniques. The differences between the black and the white colors. White will reflect the most of the light. Barcode reader, white will reflect most of the light, while black absorbs the most of the light. White reflects and the black absorbs. A patterned tag, black and white, reflects light in a specific way, allowing the easy decoding. This reflection of the light in a specific way try to decode and understand the component. Then code reader in the assembly process. Code reader in the assembly process is the sensor mechanism. Light source. The sensor mechanism consists of light source, receiver are on the same side. Works only when the tag is within the specific range from the light source. Then inductive sensor in assembly process. Inductive sensor in the assembly process. This inductive sensor, the main function is it detects and monitors the position of the components. It detects as well as monitors the position of the. It detects and monitors the position of the components. Is used precise positioning. It uses precise positioning of the components. Its working principle is based on changes in the inductance value of the PCB coil. The changes in the inductance value of a PCB coil, it will work. AC current flows through the coil, PCB coil, generating a specific inductance value. When an object comes near the coil, the inductance change.
भेजो.
So Gladson sir, sorry for the interruption. So right now you can speak, sir. Please unmute your mic and speak, sir. Alvin sir.
Okay. This working principle is AC current flows through the coil. Due to the flow of the current, it generates a specific inductance value. When an object comes near the coil, the change in inductor, there will be a change in the inductance. This indicating the presence of the object nearby. So the application is detects objects in proximity. It determines the position of the object and the movement of the object by analyzing the inductance changes and their rate of the inductance change. Then capacity sensors, the main function is to check the electrical component, functional check of the electrical component. It detects around parts and their positions. The advantages of the capacitive sensor is it ensures the precise position of the part and detection of the part in the assembly line. Detect the part as well as precisely position, locate the components in the assembly line. Its working principle is it uses alternating voltage causing the electric field to change the direction. It uses the alternating voltage causes the electric field to change direction. This change in electric change in the direction of the electric field causes the capacity balance to change. So the change in the effect of the capacitance also, with the change in the capacity balance, we detect the object position and the presence. Larger and closer objects increase capacitance, enabling the detection. If the capacitance increases, the object is very closer, as well as the object is very larger. Likewise, we can detect the position of the object in the assembly line by the change in the capacitance values. It is used for position detection as well as the part detection in the trim line. Then photoelectric sensors. This main function is to determine the exact position. Photoelectric sensor is used to determine the exact position. It is used for approach checks and the distance measurement. Whether the object is approaching the sensor, otherwise the distance between the object and the sensor. It works by detecting the reflected light. It works based on by detecting the reflected light. Its working principle has a light source and a reservoir. It has a light source and as well as a receiver. A receiver detects the reflected light to the sense object presence and the position. A receiver detects the reflected light from an object to sense the object presence as well as the position of the object in the line. Then photoelectric sensor would have types. First one is reflective model, second one is through beam model, the third one is retroreflective model. The reflective model is light emitter and receiver are on this, both on the same side. Sensor detects the light reflected from the target. Then through beam model, the light emitter and the receiver face each other, opposite to each other. When an object blocks the light, its presence is detected. The third one is retroreflective model. Light emitter and receiver are on the same side. Light reflects back from a reflector. If an object interrupts the reflection, then it will be detected. Then pressure sensor. What is the main function of the pressure sensor? The main function of the pressure sensor is monitor the suction pressure of the grippers. The suction pressure gripper is used to install the windscreens. It is essential for transferring the components to install the windscreen. The working principle is uses different sensing methods like inductance or capacitance change. Change in inductance or change in capacitance uses different sensing methods. It commonly operates on the piezoelectric effect. When a pressure is applied, piezoelectric metals generate electricity. The amount of electricity is proportional to the pressure. How much amount of electricity produced is related to the pressure. The output is measured as an electrical signal. The output of the pressure is measured as an electric signal. Then chassis line 1. In automobile assembly shop, the next station is chassis line 1. It integrates key components like suspension, silencers, and fuel tanks. In this chassis line 1, it assembles the suspension, silencer, and the fuel tanks. It ensures the quality assessment and monitoring before the assembly. First process is suspension system. The second process is exhaust system, and the third process is fuel tank assembly. In the exhaust system, pipe is cut to the required length using a automatic power saw and assembled with the silencer and the exhaust system. Fuel tank assembly, it is installed and integrated before moving to the next assembly section. Here in the chassis line, what is the role of the sensor means? It maintains smooth workflow and precision assembly. Precision assembly is precisely located the silencer and all the exhaust system and the suspension system. It provides real-time monitoring and feedback to the real-time monitoring means real-time assembly. In real-time assembly system, we can get the real-time data and feedback for correct positioning of the components. Various sensors are used for this task. First one is vision sensor in chassis line. It accurately locates the brake disc during the assembly. The vision sensor in chassis line, it accurately locates the brake disc during the assembly. It working principle is it captures an image with a camera and process it using a monochrome model. Light and dark areas are identified to determine the exact shape and the position. It uses a black and white sensor. This vision sensor uses a black and white sensor due to minimum color variation only needed in the chassis line. It captures an image which is a black and white image using a monochrome model. The light and the dark areas are identified to determine the exact shape and position of the object. If the fixed camera allows continuous monitoring of the component position, the camera is always fixed and the component is moving across the camera. Unlike other sensors, vision sensors support multi-point inspection, enhancing the accuracy. This vision sensor support the multi-point inspection, therefore accuracy is very much high precision accuracy is we can get. Then purpose of the capacitive sensor. Next vision sensor we use capacitive sensor. The purpose is to monitor the release of the work step in the assembly process. Its working principle is it detects objects. How it detects object means based on changes in the capacitance when they come into contact and sends data to the central control system, which then adjusts operations accordingly. Based on the data, it detects objects based on the change in the capacitance values. This data, based on this data from the central control system, it adjusts the operations accordingly. The key feature of this capacitive sensor is smooth workflow, precise control. It helps in automated decision making based on the sensor feedback. Because in the chassis line, one or more machines are working, one or more machines machine parts are moving. It should not collide with each other. So the sensor change in the capacity value of the sensor detect the position and the size of the object, and it will gives information to the central control system, and from the central control system is go to the feedback system. From the feedback system will go to the control unit to control the current operation according to the data. Then laser sensor. It consists of a laser source and a receiver. It application for safety content and the length measurement. Safety content means to stop the process if an object interrupts from the damage. If any object interrupts the laser beam, it will suddenly stops the process to prevent from damage. The length measurement. It ensures precise cutting of the exhaust pipe by guiding the automatic saw. The length measurement means for silencer, cutting the exhaust, the silencer pipe, you got to precise cutting. This laser sensor is guiding the automatic saw to precisely cutting the silencer. Then key benefits. It enhances safety in restricted areas. It improves accuracy in component measurement and cutting. Then drivetrain integration. In the drivetrain integration is power transmission system, mechanical power transmission system in the chassis only. Drivetrain means engine, drive axle, disc and drum. Then cooling system, radiator, condenser, coolant pipes and blower connections. These are all integrated in the drivetrain. The process drivetrain installation, it is called as mechanical marriage, as it connects major power transmission components. Then radiator, condenser, cooling system components are attached. Then fasteners. Fasteners means bolt, nut and all other screws, nuts, rivets, all other components are ensuring the stability. The next one is role of sensors in the drivetrain integration. It monitors the entire process for precision. It ensures correct placement and fastening of the components. It ensures correct placement and fastening of the components. Then inductive sensor in chassis line 2. The purpose of this inductive sensor in chassis line 2 is detects and monitors the position of the components. It detects and monitors the position of the components. It ensures correct placement during the drivetrain integration. What working principle is, it measures changes in inductance when object is nearby. When object is nearing, the inductance value will changes. So it will help in locating the components and fixtures accurately. The importance of this inductive sensor is it ensures precise alignment of the drivetrain parts. If the drivetrain part is not precisely aligned, because based on the sensor only, it aligns the parts in the put the parts in the exact location. It improves assembly accuracy and the efficiency. Then RFID sensor. Then RFID sensor in the chassis line tone. The purpose of this sensor is to identify different components and sub-assemblies. It links components to their respective vehicles. Identify different components and sub-assembly, as well as identify different components and sub-assemblies, as well as link that components to their respective vehicles is the main purpose of the RFID sensor. Its working principle is it uses radio waves for detection and the data extraction, for detecting the component and getting the data from the component using the radio waves. Then how it extract data from the RFID tag. It contains a memory chip and an antenna. This tag sends the stored data to the reader for the identification. By this, we can identify the different components and sub-assembly and link the components to the particular vehicle in the particular position correctly. This importance is it ensures correct component tracking. The importance of the RFID sensor is to ensure current component tracking. It improves efficiency and accuracy in the assembly process. Then laser sensor in the chassis line 2. What is the purpose of the laser sensor? Means it prevents collision and protects the restricted areas. It prevents collision as well as to protect the restricted areas. It ensures safe movement of the autonomous transport arms. That automation machines, that is a autonomous more number of autonomous transport arms to fix the parts. To save movement of the autonomous parts, the laser sensor are used. Its working principle is it detects the approaching components using the laser. Which component is approaching the workstation? Using laser technology, it will detect. Then it sends feedback to adjust the it sends feedback to the autonomous arms or the machine which is going to perform the operation, assembly operation. Then slow down the movement to prevent the damage. Okay, this is the working principle of the laser sensor. Its important is reduce the risk of collision. First, it will reduce the risk of the collision, then enhances safety efficiency in the assembly process. Then final assembly section in the automobile manufacturing, that is wheel assembly, seat installation, door assembly, fluid filling and accessory installation. Wheel assembly means wheels are mounted on the vehicle. Wheels will be attached to the vehicle. Then seat installation means specific seats are identified using the RFID and installed with the suction grips. The doors are selected and attached to the vehicle. Fluids like brake oil, engine oil, coolant oil are filled automatically. Then remaining accessories are added in the final assembly section. The role of sensors in the final assembly section is bonnet check and the final testing. Bonnet check means sensors confirm if the bonnet is open before the fluid filling. To fill the brake oil, to fill the fluid oil, the bonnet must be open. So the sensor confirm if the bonnet is open or not. Before injecting the from the pump, oil pump, it will sense. Final testing. Vehicle is tested on different weather and road condition. To get the data, we can use the sensors. It ensures the vehicle is fully assembled and ready for testing. Before testing, it is all the sensors are tested to get the correct data of the vehicle, whether all the components is attached or secured to the correct position or correct location. It will get the full data and enhances accuracy and efficiency using the automation and the sensors. Then vision sensor in the final assembly. Vision sensor. What is the purpose of the vision sensor? It identifies and matches the pattern of the wheel disc. It ensures correct wheel mounting. It ensures the identify the wheel disc and matches the correct pattern of the wheel disc with the vehicle. Particular vehicle, each and every vehicle has a different pattern of the wheel disc. For the particular wheel pattern, you use the correct pattern of the wheel disc and you select it and ensure the correct wheel mounting. Its working process is it captures the image of the wheel disc. Then it uses a monochrome model to analyze the pattern. Analyze it, the pattern of the wheel disc is analyzed with the monochrome model and compares the data pattern with this standard set. Already here it has some inbuilt standards inside the machine, so it compare the standard whether this pattern of the wheel disc pattern is suitable for this vehicle. It compares the standard pattern. Once matched, the automatic screwing arm screw secures the wheel assembly. If it is not matched, the automatic screwing arm does not perform the operation. This does not attach the wheel. So the importance is ensures accurate wheel alignment, automates the fastening process for efficient precision. Then inductive sensor in the final assembly. What is the purpose of the inductive sensor? It detects parts, their exact location during the assembly. Ensure proper integration of the small components. It working process is, it measures the changes in the inductance value, tracks vehicle movement during door assembly and other integration. It processes data to identify part positions accurately, to position the part accurately. It tracks the vehicle movement during the door assembly and other integrations. It processes the data to identify whether the position of the part is accurate or not. It ensures correct placement of the components, improves precision in the final assembly. Then photoelectric sensor in the final assembly detects the state of the bonnet, open or closed. The photoelectric sensor detects the state of the bonnet is open or closed. It identifies the presence of the vehicle at the different stages. Then working principle, it uses light intensity to detect objects. Different light intensities help in accurate detections of the component. Importance, it ensures proper workflow in the final assembly, helps in smooth and efficient final assembly. Then RFID tag, as usually it identifies the correct seats for each vehicle, ensures accurate seat installation. It uses radio frequency waves to detect the particular seat and read the seat information, and it fixes in the vehicle. It prevents seat mismatching. Most important is it mission because front seat will be fitted in the front and the back seat should be fitted in the back. Likewise, speeds up the assembly process. It speeds up the assembly process. Then pressure sensor. What is the purpose of the pressure sensor? It monitors the suction pressure of the vacuum gripper, because the vacuum gripper only going to fix the hold the take the seat and hold the seat and position the seat. This is the vacuum gripper only hold the front glass, windscreen glass of the vehicle, because the proper pressure should be maintained. So for taking the windscreen glass, that the pressure is different. For holding the seat, the pressure is different. So monitor the suction pressure. We can use this pressure sensor. It is proper positioning and assembling of seats in the vehicle. Its working principle is it detects pressure changes in the vacuum suction system, and the same function is as in the trim line also. It performs the same function. It ensures secure handling of seats and prevents misalignment and dropping during the installation. Misalignment it prevents misalignment as well as the dropping during the installation. Then flow sensor in fluid filling. It monitors the fluid rate. As well as the during the coolant and the oil filling. Engine oil filling and coolant oil filling monitors the fluid flow rate. It helps in calculating the exact amount of the fluid to be filled. The working principle is based on the cross-sectional area and the sensor data. Flow measures flow based on cross-sectional area of the engine as well as the cross-sectional area of the oil pump. Different methods are used to detect the fluid flow. Then flow sensor, types of the flow sensor: mechanical flow meter, vortex flow meter, ultrasonic flow meter, and magnetic flow meter. This type of flow sensor are used. This mechanical flow meter uses piston or turbine to measure the flow based on the water speed. Then vortex flow meter detects vortices created by an object in the fluid stream. Then ultrasonic flow meter uses sound waves to determine the flow rate. Then magnetic flow meter uses the magnetic field to measure the volumetric flow. It ensures precise fluid measurement in vehicle assembly and prevents overfilling or underfilling of the fluids. It is very important of the flow sensor, because overfilling of the fluid also no need, and underfilling of the fluid will lead to damage of the equipment. The importance of sensor in maintenance of the assembly. Crucial role in workflow. Sensor ensures smooth and efficient production process. Any malfunctions can disrupt the operation and cause delays. Possible issues due to faulty sensor. What are the possible issues caused by the fault? If the one time two-T code reader get fault means seat identification will not be correctly, do not correctly identify the seat. If the inductive and capacitive sensor become fault means position of the components will be wrongly, it will be positioned. If the photoelectric sensor will not work properly, it misguides the part positioning or fails to detect the obstacles leading to the collision. If the pressure sensor is not working properly, weak suction grip may cause components to drop, fall, and break. The vision sensor is not now working properly, failure to locate the brake disc correctly. And if the laser sensor, laser sensor, it will allow the unauthorized entry into the restricted zones, causing the damage or the safety risk. Next one, the impact of the sensor malfunction. If production delays due to the conveyor belt stoppage, if the sensor is not working properly, the conveyor belt will stop, therefore production will stop. Damage to the vehicle's components and the automation equipments, automation machineries involved in the production process. Then potential safety hazards for the workers will also possible if the sensor is malfunction. Regular maintenance is essential for sensor reliability and ensure smooth operation, safety, and high quality production is required. For tire pressure monitoring sensor, a direct tire pressure monitoring sensor and the indirect, two types in tire pressure monitoring sensor. It uses MEMS based pressure sensors and RF transmission to monitor the tire pressure in direct tire pressure monitoring sensor. In indirect tire pressure monitoring, it uses the wheel speed sensor. It uses the wheel speed to detect the underinflation. Battery-based tire pointer powering system, tire pressure monitoring system. It is mounted on the rim of the wheel. It includes battery for the power source, MEM-based pressure sensor, low power microcontroller, ultra high frequency transmitter. It consists of. Then key components are acceleration sensor, pressure sensor, and the voltage sensor. The acceleration sensor detects wheel rotation to identify the left and the right tires. Activates the power saver mode when the tire stops moving. Then pressure sensor, it measures the tire pressure, works with the temperature sensor to monitor the heat levels and prevent overheating of the pressure sensor. Then voltage sensor, it monitors the battery life of the tire pressure monitoring system. The key components of the tire pressure monitoring are RF signals. It helps to differentiate front and rear wheel based on the signal strength. Then TPMS, tire pressure monitoring system design and efficiency, it uses MEMS technology for compact size. For small size, it uses MEMS technology, tire pressure monitoring system sensor. It integrated lithium battery to power the system. Advanced localization techniques improve tire position accuracy and system efficiency. Then MEMS-based engine management system. MEMS-based engine management system. It is to reduce the tailpipe emissions. It uses a microprocessor-based engine control unit to maintain a fixed air-to-fuel ratio. To maintain a fixed air-to-fuel ratio is used the microprocessor-based engine control unit. It reduces the unburned fuel and optimizes the combustion efficiency. It's very much useful for the vehicle performance. Airflow and exhaust monitoring. Airflow and exhaust monitoring. This feedback sensor monitor the air intake into the engine and the exhaust from the silencer. Mass airflow measurement methods. Direct, it uses hot wires mass airflow sensor. Indirect method is uses manifold absolute pressure sensor and electroceramic sensor at the exhaust. These are the sensors used in the engine management system. The map sensor. The map sensor used in engine to estimate the air density with the temperature sensor for accurate mass airflow and measurement. And the silicon-based barometric pressure sensor helps with altitude compensation, exhaust gas recirculation control. Then in-cylinder pressure monitoring is there. This pressure sensor measures cylinder pressure for engine combustion control. For the proper combustion, we need to maintain the proper pressure. This pressure sensor measures the cylinder pressure to maintain the proper combustion. It helps turbocharger operation. It regulates the cylinder fuel injection timing and exhaust gas recirculation to reduce the NOx emissions. Then engine-based management system, in-cylinder pressure monitoring. It uses piezoelectric ceramic sensors. It is used in diesel engine glow plugs to monitor high cylinder pressure. Two methods of measuring the mass airflow without considering the pulsating air pressure. Another one is considering the pulsating air pressure. The sensors are placed in the bypass channel of the air intake to calculate the airflow. In the pulsating air pressure method, uses thermal flow sensors at upstream and downstream positions. A combination of airflow and thermal sensor detects the mass airflow correctly. That's all about the types of sensors in the automobile and aircraft applications.
Thank you very much, sir. Thank you very much
Thank you.
for sharing your wonderful thoughts and ideas about the topic. And thank you very much for your sharing your valuable time with us. Once again, I thank you very much, sir. Participants, the feedback link is posted in the chat box. So kindly fill the feedback form before 10 p.m. today. So let us all join for the next session on tomorrow 6 p.m. with Sharply. Thank you. Thank you right now. Thank you, sir. Alvin, sir, thank you very much, sir.
Thank you, sir. Thank you.
Participants, kindly note that tomorrow 6 p.m. the FTP session will third session will start at 6 p.m. So all of you kindly join the time. Join on time. Thank you very much, sir.
Thank you, sir.
கொஞ்சம் இதை அனுப்பணும்.